sort of a motivation from a number puzzle, I guess. Somebody wanted to know if you could come up with a neat computational way to determine if something was a multiple of 7. Now, it turns out this little theorem or this little result is actually, it's about as tedious and time consuming as just doing the long division. Now, this might be slightly more useful for larger numbers. This number is just shy of 1 million, but you're supposed to prove that 999,999 is a multiple of 7 using modular arithmetic. And again, you know, you could do this by hand and finish the problem, you know, but in any event, I think it's still kind of an interesting result. Now, you notice we have a result right here that says it's a number theoretic result. It says that n is a multiple of 7 if and only if n minus u. Now, y'all, u is just the unit's position. Like this example right here, u would be 6. U is just the unit's position in the decimal expansion of the number. Okay, but you can see what we're doing. We can scale this down by multiples of 10, which is, you know, it's kind of slow, but at least you can get it done. Now, so for this example right here, n equals 336. 6 is the unit's position. Can I get that highlight? Yeah. 6 is the unit's position. So this says the number itself minus the unit's digit. So that's 336 minus 6, which is 330. But 330 divided by 10 is just 33, and 33 minus 12 is 21, which is certainly a multiple of 7. Okay. Now, again, not advertising this is the best way. Again, if those of you that can do long division, you know, would already have this done maybe by now. But now, and also I think it's about 7 times 48. I'm not sure. 7 times 48 sounds right. 7 times 48 is this number 336. Now, but we do have a larger number that we're asked to make that determination on. So it turns out that this is an iterative process. So let's take a look at how the steps we go. All right. Now, you can see, as I've said, this isn't the most efficient way because you're only scaling it down by a multiple of 10. But in this particular case, for the very first iteration, 9 is the unit's position, right? So you see a 9 right here and a 9 right here. All right. And then I did all the arithmetic for you. And notice how we got it down to this number right here, which is a 5-digit number. But, you know, this is not something that it's still kind of tedious. You could do this one by long division also. But if again, at the second iteration, you're going to have 1. You're going to have 1 as your unit's position. All right. And then you scale it down to this 4-digit number. Okay. So you can see we are making progress. We're getting down closer to a number we might be able to visually inspect and note that it is a multiple of 7. So now in this case, 6 is the last digit. Okay, 6 is the last digit. And so when you do the arithmetic on this, you get it down to a number that at least is a 3-digit number, which turns out to be 7 times 141. So we've shown that this is a multiple of 7, 999,999. Again, I think it's kind of an interesting result, but computationally, you would have already had it done if you just did the long division. Okay, hope you guys enjoyed.